Hello and welcome. In this video we're going to look at 7.8 example 5, which is the integral from 0 to 3 of 1 over quantity x minus 1 to the 2/3 dx. This one's a little tricky because where is the discontinuity for this function? Can you tell me the x value? If you said 1, that's correct. When x equals 1, the bottom of that fraction is 0 and 1 over 0 is undefined. So therefore the function is discontinuous there. And 1 happens to fall inside of the interval from 0 to 3. That's what we're trying to find the area under this curve over. That came out a little funny. So it's a little bit tricky to pick out because here you have to think about where the function is discontinuous and if that x value falls inside of your interval that you're integrating over. That's not something that we really had to worry about back in Math 180, or even in this class up to this point. So now that you know that if you do have a discontinuity, you have to deal with it, you have to treat it as an improper integral, now we can do something about it, but you'll want to be on the lookout for these kinds of discontinuities that are inside of your interval that you're integrating over. So it's a little bit subtle, a little bit tricky, but we are going to do this problem. So the way we're going to do this is take that discontinuity, that x equals 1, and split the integral up into two integrals based on that discontinuity. So this is the integral from 0 to 1 of 1 over x minus 1 to the 2/3, make the 3 a little better, dx, plus the integral from 1 to 3 of 1 over x minus 1 to the 2/3 dx. Now each of these integrals is also an improper integral because it has a discontinuity at its endpoints. So the way we're going to handle these are replace the discontinuity with t and then let t approach the discontinuity. Here for the first integral, it's from 0 to 1. So if we think about our t value inside, it's going to have to approach the discontinuity 1 from the left. So we have the limit as t approaches 1 from the left of the integral from 0 to t of, and let me just get set up so that we're ready to find the antiderivative. So I'm going to write x minus 1 to the negative 2/3 dx plus, and then we have the limit as t approaches 1. Now in this integral, our interval is from 1 to 3. T is in the middle. And so this t is going to have to approach 1 from the right. This is a different t. This is green tea, and this is black tea. So bad. And yet so good. All right. Now we can find the antiderivative of the first integral. Remember, we add 1 to the exponent here to give us a 1/3, and then divide by a 1/3, which is like multiplying by 3. So we'll have 3 times x minus 1 to the 1/3. And there isn't any, if you can think about doing a mental u substitution, but if you let u equal x minus 1, the du is just dx, and so there isn't any kind of constant that modifies the coefficient at all. So we have 3 times 1 over quantity 1, x minus 1 to the 1/3 from 0 to t. Then we have plus the limit as t approaches 1 from the right of 3 times x minus 1 to the 1/3 from t to 3. We'll plug in our limits of integration. I'm going to give myself some horizontal space here. we have to continue writing those limits because those are actions that haven't happened yet. We got to remember that, to do those actions at the end. So then we have 3 times t minus 1 to the 1/3 minus, and then let's take a moment to think about what happens when we plug in 0. We'll have 0 minus 1, which is negative 1. Negative 1 to the 1/3 is not undefined because that's an odd power root. Negative 1 to the 1/3 is just negative 1. And then times 3 is negative 3. So we have minus a negative 3, which is plus 3. Then we have plus the limit as x approaches 1 from the right of. Now when we plug in 3, we're going to get 3 minus 1, which is 2, to the 1/3 is just the cube root of 2, and then we have 3 times the cube root of 2. So 3 times the cube root of 2 minus 3 times t minus 1 to the 1/3. Now we can plug in our limits of integration, our t value that we're approaching in each of these. And when we do that, we get t is going, the 3 times t minus 1 to the 1/3, when we plug in t equals 1, that goes to 0. Same thing with the second limit, goes to 0. So at the end of the day, we get 3 plus 3 times the cube root of 2. So we've evaluated this improper integral. That's the area under this curve of this function from 0 to 3. And figure 8 shows a picture of that. You can see that the integral is split up into 2 integrals, one from 0 to 1 and then one from 1 to 3. So the 0 to 1 integral evaluates to 3, that's the area under that curve. The 1 to 3, the area under that curve, is 3 times the cube root of 2. And when we add them together, we get the total area under the curve from 0 to 3. Now we can also say that the integral converges because we got a finite number. You can plug this into your calculator if you want. You'll get some finite number. Great. So thank you for watching, and see you in the next video.